Welcome to the world of humanoid robots. Today, we're diving into the latest advancements that are pushing the boundaries of what's possible. Westwood just unveiled a humanoid robot that can run at 10 kilometers per hour, balance on rough terrain, and react 1,000 times per second. Meanwhile, 1X is showing off a robot that loads dishwashers, picks up leaves, and places pillows completely on its own. These aren't just flashy demos, this is the next phase of robotics, and it's moving fast. Let's start with Westwood Robotics' Themis V2. This thing stands around 5 feet 3 inches tall, so picture a life-size robot that's pretty close to your height if you're of average stature. One major headline feature is its 40 degrees of freedom. That just means it can bend and twist in 40 different ways. The arms have 6 degrees of freedom each, and the hands or end effectors bump that number up by 7 for finer movements. It's a second-generation model, so Westwood clearly built upon their first iteration to make it more fluid and capable. One reason it's become so fluid is that they upgraded the arms, giving them better articulation so the robot can handle tasks that require a good amount of dexterity, like carefully picking up objects. Now, under the hood, Themis V2 features something called BEAR Actuators, which stands for Back Drivable Electromechanical Actuator for Robotics. The back drivable part means it can smoothly move a joint in both directions without that jerky mechanical motion you sometimes see in older robots. It makes the movements more lifelike and, importantly, safer when operating around humans or delicate objects. If the robot accidentally bumps you, it doesn't feel like getting whacked by a car door. It's more controlled, with enough awareness to sense resistance and adjust accordingly. Powering all that brainy stuff is the robot's AI computing capability, which apparently cranks out around 200 tops. That's tera operations per second. In plainer language, that's a ton of computing horsepower. Because of this serious processing ability, the robot can run advanced machine learning algorithms right on board, letting it respond more quickly to changes in its environment. Speaking of changes in the environment, it also has a neat little gadget for balance and motion tracking. The 3DMCB7 AHRS sensor from MicroStrain by HBK. That sensor basically makes sure the robot knows exactly how it's tilting or turning up to 1,000 times every second. Picture it almost like an inner ear on steroids, giving the robot a constant stream of orientation data so it can handle uneven surfaces, stairs, or any random obstacle that might pop up. Combine that with the Robot Operating System, or ROS, and you get a super flexible software framework that allows developers to teach the robot new skills or tweak how it behaves in specific scenarios. Westwood claims their new humanoid can walk about as fast as a typical human, and they've even clocked it running up to 10 kilometers per hour, which is roughly 6.2 miles per hour. So, if you decide to go for a jog, this robot could technically keep pace. They've been showing off some of its more extreme moves, like running, maybe even trying out a little parkour or jumping over low obstacles. The big takeaway is that they're designing this machine to handle real-world situations, not just theoretical test labs. If it's truly stable when the floor gets a bit rough or when it has to pivot quickly, that's a huge step forward in humanoid robotics. While Westwood focuses on a super-capable humanoid that looks poised for tasks anywhere from industrial environments to more personal applications, there's also 1X's robot called Neo, which is being aimed straight at your home. The vice president of AI at 1X has been posting online about how Neo is picking up leaves, loading dishwashers, and even rearranging pillows on a couch. Now, maybe that sounds mundane, oh, it's just picking up leaves, big deal. But it's actually pretty significant to see a robot autonomously spot leaves, scoop them up, and drop them into a bag without a remote operator. Autonomy is the magic word, folks. It's easy to show off a slick video of a robot moving around if someone behind the scenes is controlling it. But 1X claims that Neo is actually doing these tasks all on its own, making decisions in real time based on what it sees, how it's positioned, and where objects are located. One of their demo videos shows Neo working on what is arguably one of the most annoying chores in any household, loading the dishwasher. It picks up a cup, transfers it from one hand to the other, aligns it with the dishwasher rack, and then places it in there. It might not sound super flashy, but think about how many tiny calculations go into that. Figuring out the shape of the cup, ensuring it's not too slippery, orienting it so it fits in the right slot, and making sure the robot itself stays balanced while bending over. In the video, the dishwasher was already open and the cup was just sitting there, so it wasn't exactly reinventing the wheel, but it's a perfect example of the baby steps, or should I say robot steps, needed to tackle the chaos of a home environment. Another scenario they showcased was the robot walking over to a couch, picking up a cushion, and placing it down neatly. It's pretty interesting to watch it keep its balance while leaning forward with the cushion, especially given that the cushion itself is soft and somewhat unwieldy. Anyone who's tried to get a toddler to place a pillow in a corner without toppling over might appreciate how many balancing corrections are needed. The 1X team emphasizes that these examples, while relatively straightforward, illustrate the complexity of real-life tasks. Homes are messy and unpredictable. You've got rugs, pets, children running around, and furniture that's never exactly where you left it. To perform tasks effectively, a robot has to handle all those variables without getting jammed up when something changes unexpectedly. According to the 1X Vice President of AI, everything you see in their demos is driven by data and a comprehensive network that controls full body motions, from the lower body to the arms and the spine joints. They're using reinforcement learning AI for the lower body and merging that with the rest of the system to achieve graceful movements. He even draws parallels to the idea that a robust consumer solution, which in this case means for everyday household tasks, can ultimately generate extremely valuable data for training more advanced general-purpose intelligence. It's the same kind of argument that Tesla has used for its self-driving program. The more data you collect on ordinary roads with average users, the better your AI becomes at handling all those weird corner cases. If you try to confine your robot or your AI to some very specialized and controlled space, you might not get enough diverse data to level up the intelligence as quickly. This is why 1X is specifically gunning for the home environment first. They're calling it the final boss of robotics because it's an absolutely unstructured environment full of a never-ending list of tasks. If a company tries to tackle robotics in smaller, narrower contexts, like a warehouse where everything's neatly arranged and predictable, that might sound easier at first. But ironically, you can end up in a situation where you're not exposing your AI to enough variety. In a home, one moment the robot might need to pick up a piece of laundry, and the next it has to deal with the pet dog wandering into the room, or it might have to open a jar of pasta sauce, then realize that the jar's lid is stuck and needs extra force. Those little scenarios provide an avalanche of new data, training the AI to handle unplanned events. The argument is that a highly unstructured environment could speed up the development of a general intelligence by constantly challenging the robot with fresh tasks. The folks at 1X are being real about where things stand. They're not claiming their robot Neo can jump from loading the dishwasher to doing laundry without hiccups. It's not there yet, but the idea is to let the robot keep trying, make mistakes, and learn from them, just like how AI models improve by collecting tons of data over time. They even compare it to self-driving. Structured environments like highways don't give you enough challenges to grow. Homes, on the other hand, are chaotic, which actually helps the robot get smarter faster. So yeah, between Westwood's Themis V2, packed with serious hardware, sensors, and AI muscle, and Neo, which is out here doing leaf pickup and placing couch cushions on its own, we're seeing major steps toward robots that can handle real life. It's still early, but these are the kind of breakthroughs that could one day give us general-purpose robots that do way more than just vacuum. The future's coming fast, and it's looking pretty wild. That's it for this one. Hope you enjoyed it. If you haven't already, hit that subscribe button. Thanks for watching, and I'll see you in the next video.